obviously the name Google has been synonymous here in California for with innovation and with data analysis and all kinds of other things. And so what we wanted to do here was really, I said, get one of the leading experts in AI, but not just AI, applied AI, so real practical uses. And we're going to hear now from someone who runs a large team of engineers and PhDs working on some of the most complex AI problems that we have. So please join me in welcoming Scott Penberthy from Google.
Thank you very much. You've got an hour and a half, is that correct, for this talk? Hour and a half? So I've got you for the next 15, 20 minutes. And what I thought I'd do, you see that title up there? It's probably not what's on your calendar, right? You're seeing a WTF moment right now. Because about 6 years ago, I was working with the board of Price Waterhouse. And I was just minding my own business. My background is I'm an AI nerd. I went to MIT, studied AI back when it didn't work. And eventually graduated and spent my career doing web things. And I was on the board, working with the board of Price Waterhouse. And a fraternity brother of mine sent me this post on Facebook. And the post had the caption, WTF. And my mom goes, what does that stand for? And I said, oh, wow, that's fantastic. And what it was a posting of DeepMind and some research happening in London. And when I saw this demo, it blew me away. It was a computer program, 4 pages of code, all math. It played 50 Atari games better than any human being. And you look at this and like, how does this thing actually work? And what I want to share with you is a technology that we at Google saw in 2010. We thought it was a little crazy, so we only put 2 summer students on it, just to try it out. 2 years later, we spent $500 million buying a company called DeepMind just to keep doing what they're doing. And then we started to play with it internally. We said, what if we use this tech for real? Like, what if we use this to reimagine how we run Google, how we do YouTube, how we make money? And they said, well, we can't do that, because this is going to blow away all our servers. So we spent $10 billion, and we spent another 10, and another 10, reimagining the entire infrastructure to handle this. And I want to share that with you today. It's a technology that you grew up in algo. You guys know about know your customer, anti-money laundering, doing financial risk measurement, all kinds of things you do every day. This new technology is, for the first time, a major breakthrough in science, physics, mathematics, computer science. It's all consistent. And the math I'm about to show you is the same math that's used in quantum computing. So we think we're getting closer to something. And we really believe this is the first true tool of thought, a tool of the mind. And what I want to do for 20 minutes is to show you how this works. You've heard about AI, you heard about deep learning and machine learning. This will give you a sense for what's actually going on under the covers, and then let your imagination flow for how you can use this even like literally next week to start making money for your firms. So let's see if this clicker works. That's me up there. Let's see. So this is what some engineers thought. They said, we've been writing software for a long time, but up here is so much better than what we could write. So let's try a new type. They called it general AI. And the idea was, this is a loop of how animals kind of behave. You observe the world in blue. You're driven by something in green, chasing like survive, fall in love, don't get eaten, kind of like animals. And then you take an action in the world. The environment changes, you observe, and you know how to do this. You learn everything else. Everything else. So they thought they'd do this, and this is 2010. 2 engineers, one in London, one in Mountain View. And what they said is, they said, you know what we're going to do? We're going to give up on computer science the way we were taught, which is ideas are sets, and set theory, and procedural languages. We're going to use an idea from 1952. The idea was first proved 60 years ago in 1958 in a perceptron. The idea is that concepts are vectors. Vectors. What this means is I can actually do mathematics on thought. I could take Paris, I could subtract France, I could add England. The computer should say, London, and sort of be able to do math. And the idea is that what I could do is, if I could observe the world in blue and here, and I see an outcome in red, like Newton, what I want to do is figure out some function that goes from the input to the output, just mathematics. So I describe the world and what I'm seeing as a tensor, which is a structured vector, and I describe the output as a tensor, and I use immense computing power to figure out how to go from input to output. Now, the first place this was tried was by Geoffrey Hinton, who looked at the way the brain works. And if you look inside a brain, you'll see neurons in the neocortex, which is the gray thing folded up in your brain. The reason it's folded is to give you the most surface area. And inside there, you've got layers of neurons. And if you look at half your brain, half of it is for vision, so you can see and eat, and language, so you can communicate. And the way it works is that you see a picture here, like this picture on the left, and we can encode that as a tensor. A tensor basically is taken that's like a JPEG image, and you can record, like in a big spreadsheet, every pixel, how green is it, how blue is it, how red is it. And you get a big sheet of numbers. That's a tensor. And what you do, like the brain, is you wire it like an optic nerve on the bottom. So you take the first pixel, and you wire it to an artificial neuron. It's literally like just an Excel spreadsheet, and you're wiring a number to a number. And that's what happens in your brain. You see something in your brain here, it activates the neocortex by literally going through an optic nerve, and it touches a set of neurons at the back of your head. Then those neurons are connected to a layer above it, and they fire about every 5 milliseconds, about 200 times a second. So the way this works with deep learning is you give numbers, and then you connect it with artificial neurons, and they're connected layer upon layer, and then at the very top, you have a simple vector that says, is this a cat or is this a dog? All it is a tensor, like a column in a spreadsheet, that has a check mark for what you think it is. And here's how this works. You give it an image, and you fill this thing with complete noise, just random noise. And as it runs through the calculations, it's all random, just like a baby. And it comes out and it goes, oh, that's a squirrel. Like, no, that's a dog. So what the math does, it starts at the top of the output layer, and adjusts these little weights on the neurons, so the next time it sees an image, it's more likely to say dog. You show it again, and it goes squirrel. It's frustrating. Show it again, it goes squirrel, maybe dog. And after a number of times, it changes the weights. So it's learning how to change the adds and multiplies so that you can go from the input tensor to an output tensor with a function. That's deep learning. So we made our first product with this and said, well, how are you going to use this? I said, well, how about software that gets better the more you use it? That'd be a cool idea. So we took this idea from research from Geoffrey Hinton and Fei Li from a contest, and we called it Google Photos. And the first product was basically upload your photos. I said, yeah, then what else? Well, that's it. Well, what are you going to do with it? Well, search for something. So you type in some word, and you don't have it, and you say, type in beach. It doesn't find it, so you select the beach. We use that to train the network. And then we record all those and feed it back in. Next time you type in beach, beaches start showing up. And so as you use this, your use, the customers using your business, are teaching your business to get smarter. There are companies like this in your sector today, starting up not too many miles away from here, doing this exact same approach. So we took that, and that's the thing on the left, the encoder. It goes from a wide, big matrix down to 1,000 things you're looking for, called the encoder. Some young adults looked at this and said, hey, remember what our parents used to do? They'd play albums backwards in the 60s. What if we played this thing backwards? Could we actually go from concept to have it create pictures for us? And the idea was, could I actually, so it flipped it across and said, well, I don't know what to guess. Well, let's give it a hint by wiring up from the left to the right. It's called a fully convolutional network. And the idea here is, can we not just identify a picture of cat or dog, but tell me what every pixel is? This is 2015. 2 years after that idea, it took basically a supercomputer running at night to grab the frames from a video and train it to try to label every pixel, and it kind of drives like someone has had too many cocktails. But the idea here is it's kind of fuzzy, you can kind of see it, it needs contacts, but it's starting to get the idea that gray is sky, and you see with the road, it's starting to identify things. They took this as a challenge, and this was taking a supercomputer all night to basically do a few seconds. Well, the Chinese were looking at this as well. Fantastic area of AI research. Look what they did. 2 years later, they're doing this at 30 frames per second on a standard computer. Now, of course, they published this, and back in Mountain View, it's like the who can do better. So they said, well, we got to do better than this. So this, if you ever use Photoshop and you're trying to put something on your website, you want a backdrop or say you're at something or not, what this does is it actually identifies pixel by pixel on a smartphone without lowering your battery. It can actually identify the background from the foreground and actually go around hair, for example. So for example, you could use this, I imagine, for doing a hangout. So you put the office behind you and say, yeah, I'm not at the beach, I'm at the office. And you can have a hangout. Just don't raise the martini glass. And so that's the idea here. And we did this, and they said, well, this is kind of hard. You need nerds like me to help you do this. And so the board asked the team, hey, could you do an AI that does an AI? They said, what do you mean? Well, if tensor in to tensor out, you got thing in that function in the middle, have an AI figure out how to search for functions. OK. So we tried this and released the research last August. We now have an AI that, this is the way you read this graph, is on the x-axis, it's the number of connections in the neurons in millions, from 0 to 30 billion. On the y-axis is how accurate you are in identifying 1,000 things from an image. The yellow represents human research, which means they start out small, and they get more accurate with bigger and fatter networks. The AI we built, the first network at first was no good, but eventually became good enough. It was better than the first one in 2012. And then after just 20,000 iterations, it produced a network that's smaller and faster than the best researchers in the world have been working on this for 20 years. So what that's done is, this is a graph of the use of deep learning, that technique I showed you, of basically tensor in to tensor out through a neural network. In 2012, it was nowhere in Google. It was a curiosity. To 2017, most engineers now use this as common as a database inside Google, and it's led to significant growth in our business. And they said, well, that's just images. What about business? Well, it turns out if concepts are vectors, why not reading and writing? So you could actually take an email and encode that as a vector. Think of like a matrix where you're putting the words on a spreadsheet. And then you want to have the output not say cat or dog. Guess the first 10 words I'd type in response. And we've got a few billion emails at Gmail. So you can train this, and we put this in an app called Inbox. You can have it on your smartphone, and you'll see in blue, it'll start prompting you for what to say in response to this email. That's coming from the same kind of network I just showed you, same algorithm. When we release this, 1 out of every 12, then soon 1 out of every 8 emails are being answered in one tap. It's like my people are talking to your people, but the robotic. Then we said, well, that's reading and writing, but we're humans, we communicate, we can speak. So they took the technique and said, wait a second, speech. I can listen to Scott, I can record the sound wave, and I can sample it like an image. Each sample is a sheet like an Excel spreadsheet. And then I can say, well, when I see this waveform, what's he saying in English? And that's just another tensor on the output. And I've got all the searches we've done at Google to train a language model that's far better than any language model we've ever built by hand. And it gets better every time you use Google search. So we now can actually generate speech and recognize speech in near real time. Right now, you can actually buy this at Google Pixel Buds. It's sort of an interesting version today. You say hello. Bonjour. It takes 5 seconds because you're sending it out, running through the cloud, and coming back. When we put it in your ear, hello, bonjour, it's going to come back instantly. So I started showing this to customers about a year ago, and they said, yeah, Scott, but that's not us. We're business. I said, what does that mean? They said, well, we like your fancy math, but we go by gut feel. It's relationships, it's feeling. And we really can't explain how to do this. So I think this upset the researchers when I brought this back. And they said, let's go out for a game that's all about gut feel, called the game of Go. One of the simplest games to define the most complex games in the world. And they went to South Korea, where they've got 20 years of the Go champions. And they asked the best champion, Lee Sedol, hey, who's winning? And he'll go, white. He said, are you counting? Are you doing, is this a classic opening? He's like, no, it just feels right. And he said, well, how would you move for black? And he looks at it and he goes, oh, clearly here. oh, is this a classic play? Are you doing a blocking move? He said, I don't know what you're talking about. It just feels right. So we actually encoded an AI to play this based on 30 million games from history. And then it beat the top players both in South Korea and in China. Then we looked inside this artificial brain we built, and we popped it out, and we said, just play against yourself. It played against itself, and that thing called alpha zero means zero human intervention, beat humans and beat that one 100 to 0. And it basically runs on a cell phone. So we were excited about this as nerds at Google, and the board's like, yeah, but how do you make any money from this stuff? Right? They're like, no, really? Is it? And I believe there's a challenge, and they said, well, how about let's rethink Google. What do you mean? No, let's build an AI to out-Google Google. You mean ads? Yeah, that thing. So we took ads and said, could we actually predict what someone's going to do by saying, here's the context of the user journey, and here's the output of what the ads they selected. Could you do this with a neural network? And then can you combine this with other signals to do better? Sure enough, it works. And if you ask the machine learning engineers, they'll say that's what's driving a lot of the growth. Now, there's a lot more driving the growth, but this is now fundamentally driving ads, YouTube, search, video, Gmail, and many more. And in fact, that very same pipeline is happening right now. As you're searching for these terms and taking photos and uploading them, a machine learning is actually ingesting all this data and making 1 billion inferences per second. It's ingesting the data on the left. It's exploring it in structured data called BigQuery. From that, it's preparing it to make it into tensors. That's the preparation. And these things are available from Google Cloud. You can use yourself. And then you're actually pre-processing this, which means preparing tensors to train a network. We then train a network on machine learning engine, which you can use. And we put that back online, and it's available to someone in Taiwan on the Google Home. So your interactions are training this to make search, ads, and experience and talking that much better. And the way you work with this is we'd like to have these tools available for everybody so that you can have the same tool of the mind and really explore what it means like for you. So there's 2 ways to work with us. One is you can use some of the models that you've helped build. So recognizing images. We see billions of images. We see more searches than anyone on the planet. We see more for speech and speech patterns than most people in the world. Those models are available by the click to you. The next thing is sometimes you have data scientists like yourself, or you may have other people who want to build your own models, and we have a platform that allows you to build those. And we're now working with some customers where we can build those for you by turning a crank, what we call an AutoML technique. And the way to look at this is that we have these set of technologies that's built on top of this $30 billion infrastructure off of many years of research that basically now let you add to your processes computers that can finally see. So people who are looking at stuff and doing claims, a computer can do that. People are taking forms and trying to type them in. Computers can now do that. They can do quality assurance. They can do call center things. They can actually read documents and tell you if you're aligned or not on contracts. They can listen to your customers and speak to your customers and shorten the time from going from inquiry to resolution. The next thing you can do is if you're a data scientist or you've played a little bit before with Python, it's like Visual Basic these days, it's called a co-laboratory. Our research team made us available. I believe it's free so far. And basically, this is called a co-laboratory. It's a Python notebook sitting on top of a GPU in that massive infrastructure available in 1 click. And you can now go run many of the standard examples you'll see on online courses like Coursera, Udacity, and so forth. You can actually use and run those inside this today. You can just go to co-laboratory. The next thing, once you start to figure out the APIs, they're pretty easy. If you know about REST or a simple way or have a programmer, they can use them tomorrow. Or you can even train them to build your own machine recognition for certain parts or parsing, basically OCR and all kinds of things. But if you really want to have fun, there's a lot of data sets where you have these problems on Kaggle, and this is where hundreds of thousands of machine learning engineers are hanging out. And they're actually using Collaboratory and things like it to play with data and publish it in an open standard way. And a lot of this is done in TensorFlow, which we've taken that entire software stack. The entire stack we use, it's now open source. And it's called tensor flow because we're flowing tensors through the graph, searching for that function f, like Isaac Newton. And one of the best ways that, in our team, we find to get started with AI is to help make your CMO happy, make your CFO happy. What you can do is literally just take data you're already taking on your customers and then start to use these techniques to analyze better customer lifetime value. There's a lot of techniques in CLV. Professor Wharton says a lot of people are doing it wrong, but look at CLV. You can actually have a better understanding of them, and from that, start to figure out where could you actually target a campaign to have more engagement from your customer set. Or let's say you've got 10,000 emails you have to answer. You only have capacity for 1,000. Which 1,000 first? You've got a lot of inbound phone calls in your call center, and you only have capacity for 1/10. Which ones do you answer? And are they upset? Are they happy? All using two things, simply AdWords, which is on the left, and then you combine that with the power of cloud and machine learning. And that's what my team particularly spends a lot of time on, is helping you do that so that you can take this, start with AI, start using this to drive better digital sales and marketing, get used to this new technique, and then use that air cover to start doing the really exciting things about reimagining what your business is like when you can actually have products that learn and experience users and they become better with use. So have your customers help your business sharpen itself. So this is my contact. Please do reach out on LinkedIn to connect. And you can learn a lot more about what we're doing at AI Google, for ai.google. You'll see a lot of what we're doing in cloud in terms of actually democratizing and bringing that to market. So our Google Brain team, our Google DeepMind team, Google Cloud is the way you commercialize that. What Google Cloud is allowing you to be that ninth area of productivity, that ninth new wonder of the world of actually being online. Because that same platform is one platform, one code base that drives all of Google. And it does billions of inferences per second, and it's available to you literally with a single click. So hopefully in my time I've given you a sense for my WTF moment, because when I saw this, I didn't believe it either. But what's fascinating is you can now describe problems in mathematics and have the computer find things that humans can't. So thank you very much for your time.